Coming up on Built to Last, we'll focus on the indoor systems that'll keep our home comfortable all year long.
Support for Built to Last is provided by
Unico Incorporated, manufacturers of the small duct high velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Bosch, power tools for professionals. Proud sponsor of The Green Home. Florida Tile. Expect more. SPI Incorporated, protective coatings, proven performance, and real-world solutions for 24 years. Additional funding is provided by these firms.
Now that our home's beautiful exterior is complete, it's time to move indoors to install the systems that will keep our home comfortable all year round.
We have our exterior work complete. We have our decking done, most of the grading and anything that we could get completed for the perimeter of the house for the site conditions. So now we move to the inside and focus on trying to get things done in here, buttoned up, and get some of the heating and things like that going so we can get ready to complete the interior of the house.
Product we're going to use for the heating and cooling in this particular application is a small duct, high velocity, central heating and cooling system. And in this particular application, we chose it because the very limited thermal transfer between inside and out, we don't need the big ductwork in here. We want as much built space as we can possibly get in this home. With the system we're installing, the main plenum, instead of being 8 inches by 30, it's only 7 inches round. Coming off of that are very small 2-inch ducts, which terminate into very linear diffusers, which are about yay big. So the impact on the home is very small. Another issue that makes this product very sustainable, the small duct system, is the fact that it doesn't leak. So 100% of the air cooling or heating that you're paying for is actually going into the structure to cool or heat it. There's no duct leakage. The big traditional ducts leak about 25%. This particular system, the lead rater will show it to be leaking less than 1%. And they can't put 0. So they have to say less than 1%. That's very sustainable.
There's going to be 2 units here, 2 high efficiency units. We'll be taking off right from there off the units on the air handlers. It's a high velocity system, quick to install, needs little room like most of our ductwork, cuts the ductwork, the main trunk lines in half, and gives us a much faster installation, much easier installation by going down to 2-inch high-velocity pipes. Now, the exit, the air coming out, we used to big floor registers or ceiling registers. Instead, we have a round register, a small register with a high volume coming out quickly. Takes up very little space on the floor, can be put in the corners, near the windows. It's out of the way. That's how it works. It's a good system. Hey, Bruce, how you doing?
Good, Dan. How are you?
Good, doing good.
How's the ductwork installation coming along?
It's going real good. We're just finishing up our returns down into the basement. That'll be our final connections into the mechanical room. We're looking pretty good there.
Okay.
Right over here, we're finishing up our flex. All our flex is run. We just got to make our connections, snap-ons, and that's it, and then tighten everything up, and we're looking good.
Okay, now all this ties back to the mechanical room that's below here, right?
Everything's going right into the mechanical room, whereas our returns are going to run down into the ceiling, grills put on the ceiling, with the master room downstairs being a plenum room and a master return going into the units in the mechanical room. It stratifies much better in a room like this with a high velocity system. Whereas our lower velocity systems, we have to have a return in every single room
Right, that's
in order
a
to get
typical.
that heat off the ceiling, cool for the floor to draw up. With this system, it mixes it pretty even in the room, so it works real well.
So it should be a nice comfort level in this, regardless of time of
Absolutely,
year.
no matter what height, that ceiling height or level, it should be a nice mix of air. Easier on the units, actually.
Great. And I see this system, you're able to take advantage of the soffits and things that are in the space to kind of make everything work and fit in.
That's
so.
what's great about it. Instead of a trunk line, everything fits in the soffit. As you can see, we've got 6 runs in a small soffit. If you had 6 runs on conventional, what would happen there, you'd have to have a major trunk line coming through and takeoffs,
Right.
which now you're boxing in. Whereas this, they can put a nice ceiling, finished ceiling up high. It's got a 9-foot ceiling, looks real nice and neat for the homeowner.
Great.
Works well.
Has there been any other challenges to this? I notice everything's pretty much about the same size ductwork. You're up through the floor, you're making your connections.
Yeah, the only couple of challenges coming through the floor, certain spots we had to move simply because we have heavy beams underneath, and it works out, but that's the nice thing about the Flex. It's only a 4-inch opening you have to put in. It's very movable.
Right.
So if you have any problems on the job, you can move over one space, you can move over another section and flex back to where you want the original print, because you want symmetrical always when you register, so they look good in the ceiling or look good in the wall.
Yeah, well, plus you get the balance of flow of
Yes.
air in your room.
Yeah,
so.
you keep the balance of flow by staying those registers at your end, the architect and
Yes.
the engineering getting those balanced off, so it not only looks good, the air is balanced well enough off in the room, so it's a nice mix and it looks nice and symmetrical. Everything's looking real good here.
No, it
problem.
sounds great. I'll let you get ahead. It looks like you're got octopuses coming out of the ground here.
Sure does. Wouldn't this look great underwater?
Yeah.
Our team installs the 2 units that will provide the airflow, while the ductwork, registers, and returns are installed. With the system in place, it's time to test it out and program the system for optimum efficiency according to our home's needs. Our next job is to finish installing the conduit and run the electrical wiring throughout the home.
Our electrical contractor is in the process of completing a lot of the rough-in work on the interior of the house. Quite a bit of it was done before the mason got on site because we had to have a lot of the boxes in places for our exterior light fixtures and outlets. So now they're focusing their attention to the inside. We have quite a bit of conduit to run because we have a home automation system in this house. And because of the local code requirements, all our wiring has to be in conduit. So we have to run a lot of extra piping in the house, and that's what they're in the process of now getting done. Once that's completed in place, they can start pulling the wiring and start getting things trimmed out and set to go.
Another important utility that needs to be implemented before we close up our walls and ceilings is the gas supply, which will be used to heat our home.
One of the important features about running the gas line is everything needs to be pretty well concise as far as locations and pipe runs. They want to keep things to a minimum and minimum amount of joints to prevent the opportunity for any type of leakage or something down the line. So it's very important that things are kind of laid out in a pattern to where it minimizes the number of joints, maximizes pipe lengths and things like that.
Today we're starting to bring the gas, the natural gas, into the house so that we can supply the boiler and the fireplaces, and then a future line for a outside barbecue. So we're bringing the gas in, we're going to check to make sure there's no leaks, it's properly supported, installed safely.
Had a meeting this morning with Bruce, the architect, in regards to laying out the hydronic heating piping for the first floor and second floor, routing the risers to pick up the manifolds. Talked about some information we need to roughen for the fireplaces. And then subsequently we start on the gas piping.
Planning is very important. When Rick first arrived on the job, he made an isometric drawing, laid out where the takeoffs, where the tees were going to go, so he knew how much fittings to have, which tees and adapters and reducers into the proper place. Also, how many hangers so that it was properly supported in case somebody inadvertently leans on it or push on it. It's very important that the pipe is installed parallel and perpendicular to the lines of the building and level.
We have different connection methods. On this project, we're going to use 2 of them predominantly, and one of them is threading. and using screwed fittings. That's how we're putting in the gas system. That's a traditional means. So we have machinery on site that allows us to cut, thread, and assemble the screwed black pipe. We'll also be employing the latest in methods when we do the hydronic piping. It's a pro press or press fit type system where the copper tubing and the fittings are joined, and then the fittings are crimped with a piece of machinery providing a seal.
When you're installing in this building with these engineered floor trusses, it allows a lot of room for running conduits and pipes and gas lines. So typically when it was all solid, you would have to drill a hole through each one of the floor joists. And again, you only can remove so much of the wood and how far away from the supports, so the steel's in the middle or at the end. So these engineered trusses are a real blessing. You can go right through them anytime there's an opening, as long as you don't disrupt the engineered structure.
Once everything is complete, we're going to apply a pressure test to the system to ensure its integrity before we turn the natural gas on into the piping system, and then to the piece of equipment it's tied into. I enjoy what I do quite a bit, and I try to make it like an art form. So I always try to add in a little symmetry or space so somebody who's maybe not a pipe fitter can look at it and be impressed with how it is, but never put their finger on why it's that way. And so I consider what I do as a trade, but it's certainly an art form.
Today we have the sprinkler fitters 281 on site here, and they're going to be doing a rough-in for the fire protection for the home. In the different municipalities, sprinklers are becoming more of a mandatory or code requirement. It's becoming more accepted. Before it was kind of deferred because of a cost, upfront cost, but in reality, on the newer developments, we have the water pressure in the street and things like that, so pumps don't have to get involved in the home. So it's pretty more of a simplified, straightforward system. And obviously the life safety factor is a huge benefit, and the fact that you don't have a loss to a home or structure, things like that, kind of weigh out the cost of not doing it. Also, there's insurance premium reductions if the home is protected.
The sprinkler head would be activated. It's a fixed temperature head, and it would go off when it reaches that temperature. The water will come out, smother the fire, and the fire would be out usually within a minute.
The layout becomes a very important factor in this. Even though we have open web joists and things like that, there's a lot of areas where just to get the piping work to run and cross through, we have to deal with beam locations, micro lamps, things like that. So we have some chases and things like that for the piping to work through. We're talking about a 3/4 inch copper pipe. So it's not really an invasive issue trying to get things work and routed through the home, but we also have to look at locations and coverages. So obviously a large open space, a couple heads located equally spaced gives a coverage in a room, but we run into more issues when we deal with corridors, hallways, and things like that. So, but they're not an invasive feature anymore. It's more of an architecturally designed feature, sidewall or pendant mount fixture. So it kind of just hides in the overall scheme of things. It's not something that really stands out or is invasive. So things have been done to modify to make this more of an acceptable system. It doesn't stand out as being an offensive feature in a room. So it's a great solution. It's a nice feature to have. And I think it's really the way for things to go.
We're finished installing the system that can save lives one day, and we'll now move on to our next system, which will save us money and energy every day.
We're here today to work on the mechanical insulation, which is, if you're thinking of mechanical insulation, you'd be thinking of pipe insulation. So if you'd see in a house being built like this, all the copper piping, that's what we would come in and insulate for saving energy and saving greenhouse gas emissions and making your domestic hot water, your furnace and stuff like that run more efficiently. What's unique with this house is that they brought us in to do the mechanical insulation. Typically when you see a house being built, mechanical insulation isn't thought of because a lot of people just don't see the value in that. Well, we have a software program now with the Department of Energy that actually calculates heat loss, BTU loss, greenhouse gas emissions loss for mechanical insulation. Average home has about 300 feet of copper piping. half of that being hot water piping. By insulating the domestic hot water, you're looking at about a $480 savings per year. So think about the lifespan of your home. If you were to have a home insulated, your hot water insulated when the home's being built, you know, that money being saved is just going to go year after year after year. The typical pipe covering, as we call it, or pipe insulation, is fiberglass, and it's got a paper backing applied to it, which is an all-service jacket, which helps for, obviously, aesthetics, but it also protects the fiberglass underneath it. And it has a vapor barrier built into it, so it'll stop condensation and mold growth from the insulation itself absorbing or holding any moisture. Typically, we would like to go in and take like a thermal imaging camera or a heat gun and, you know, see exactly what the temperatures are of the different systems. A lot in commercial and industrial facilities, but in a residential home, you're not going to have the system running, obviously, when it's being built. So we just run the calculations on, you know, knowing that a normal hot water system is going to operate at about 120 degrees, the water. And then you can just run the calculations to see how much you're going to save by insulating the piping.
Today we're going to start with the installation for our radiant heating for the second floor of the home. And it's our heating contractor, Mellow Air, is on site, and they're going to be installing the system, which is a panel system.
The climate panel system is a half-inch piece of plywood with aluminum stamped on the back. The panel is 7 inches wide by 48 inches long, also comes assembled for quick installation. There's 2 types of finished flooring going in on this house, and it's hardwood flooring and tile in the bathroom areas. This particular product goes down on top of the subfloor. It's not a structural product. So we're working with a clean subfloor here. It's stapled or screwed down directly to the subfloor, and then your hardwood flooring would go directly on top, nailed or glued, or in the bathroom tile areas, you'd put down a hardy board, concrete board, and then you'd mud and put your tile down on top of that. The panel comes with a groove for the PEX tubing, which is the pipe used to carry the median, which is the hot water used to heat the house. What's nice about the climate panel product is that it's very versatile. It can be used on new construction or retrofit. It can be put on the subfloor or in the walls for supplemental heat, in the walls of showers or the seats for comfort. In this particular case, on this job, it is being used as the primary heat source. A lot of other people like to use the in-floor heating, or they have the misconception that it's only good for floor warming, but that's not the case in a lot of projects. It can replace your conventional forced air system. If you're doing a small area with radiant heating, you can use a water heater. But in this case, we are hooking up to a boiler. The boiler is the primary heat source. I think we're working with well over 3,000 square feet of space here. So a conventional water heater wouldn't be able to keep up. It might be able to provide some floor warming, but it wouldn't be able to provide the primary source of heat. It's a more efficient, more comfortable system. Radiant heating, you don't hear your furnace turn on, you're not blowing dust and allergens around the house. It's a very quiet system. You don't see the return ducts, the things like that. It's a system that's completely out of sight, out of mind. It's tough to pinpoint exactly how much more efficient a radiant system is than a conventional forced air, but studies have shown anywhere from 15 to 40%. It's a low temp heating system. So another type of radiant heating system would be, say, baseboard or radiators. Those become hot to the touch. Those can actually be dangerous to a young child that's crawling over there and can actually burn themselves on it. With this, we're using very low water temperatures, anywhere from 90 to 110 degrees, where a conventional baseboard or radiator would use 180. The floor surface temperature rarely gets above 80 degrees, and in this case, it'll actually be in the high 70s. We have safety high limits and controls that will make sure that that doesn't happen, that it doesn't get too hot. The aluminum stamped to the bottom of the panel, it allows for nice even heat distribution. You'll notice that it's on the bottom of the panel and not on the top. The reason that it's manufactured that way is so that you do have wood-to-wood contact, two like materials, hardwood flooring going directly on top. You don't want your hardwood flooring ever in direct contact with the heat emitter. Two different materials expand and contract at different rates and can cause issues down the line. That's the reason that we have the aluminum stamp to the bottom of our panel instead of the top. Any type of flooring can go down on top of the client panel. Hardwood and tile being the most common type that's put down, but any type of linoleum or vinyl can be put down. You can put carpeting down, keeping in mind that you don't want the carpet too thick because it's an insulator. So you do want to be careful when designing around carpet because it will require a higher water temperature, less efficient system.
So it's very different from one that's cast in a slab as we had done in the basement area, the basement floor slab. But what's nice about this, it's the minimum thickness that we're able to deal with as an underlayment and to come back with the floor, and we don't lose that much space within the areas we're working. Between the integration of these two systems, radiant and high velocity mechanical system, we're going to have a very comfortable space that the homeowner will have this even temperature reading throughout the year, whether we're talking about winter or summer months. So it gives a nice variation for things, have a great comfort level. It's a nice solution for this type of home.
The heating system that we're using will be comfortable and efficient, but another green feature of this flooring system is that it utilizes a certified sustainable wood product. So today our Radiant floor is being installed inside, and I'm here with Danny Karch, who will tell us about sustainable forestry. Danny, what is sustainable forestry and why is it important to us?
Well, actually, Amy, it's very important to us, especially as consumers. We all try to be much more responsible in our procurement these days, and forestry certification offers a valuable proof point to consumers that they are procuring building materials from responsible managed forest. So that would mean that your plywood, your lumber, or your engineered wood products, the customers can be assured that that fiber came from well-managed certified forests.
So what are some examples of forestry certification?
There are several examples. There's a lot of criteria. There's over 100 criteria in the actual standard. But some easy ones for people to understand is, a quick one would be that when there are certain areas that are being harvested, there'll be something called clumps that we will leave, which is a patch of forest in that particular area that has been harvested for wildlife, so that they're not having to cross from one side to the other. There'll be an actual area to protect these animals in crossing. Also, another quick example is sometimes you'll see a tree. It'll be just a single limb, a dead tree that would be left in a particular area that's been harvested, where it may not look like much, but actually that tree has actually purposely been left there to act as a perch for birds of prey. So there's just a couple of quick examples of forestry certification.
Now, what about the practices? How have they evolved over time?
The practices continue to evolve. Actually, our standard goes through a full rigorous revision every 4 years. We're in the process right now of doing what we call a standard revision, where we have public input over a 1.5 year duration of time to continually improve the actual standard.
So how does sustainable forestry relate to building products?
There's a direct correlation with forestry certification and building materials, obviously, because most of these building materials are produced with fiber which comes from the forest. When these forests do become certified with those 100 different criteria in a very rigorous process and get third-party certified, the people who actually manufacture products with fiber from that forest can use the certification label to put on their products, which assures consumers that the products that they're using, whether that be plywood, panels, engineered wood products, or lumber, comes from a responsible source.
So what about our Radiant floor and sustainable products?
Yeah, I was pleased to see that floor inside. That particular product is certified to a program participant from the Sustainable Forestry Initiative.
Very good. Well, I certainly appreciate your time and expertise. Thanks so much, Danny.
My pleasure.
Well, now you've seen the systems that will keep our home comfortable. Join us next time as we continue to work on our home's interior and watch it really take shape. See you next time.
Visit the Built to Last website to learn about these topics and more. Support for Built to Last is provided by
Unico Incorporated, manufacturers of the small duct high velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Bosch, power tools for professionals. Proud sponsor of The Green Home. Florida Tile. Expect more. SPI Incorporated, protective coatings, proven performance, and real-world solutions for 24 years. Additional funding is provided by these firms.